Hi everyone, I hope you're enjoying your summer break so far. I thought I'd just put together a video aimed at any of you who are going to be taking A-level maths from September onwards. So in this video I'm going to introduce one of the most important skills that you'll learn at A-levels. It's called differentiation, and you haven't seen it before, but it does build upon some of the skills that we've done at GCSE. Alright, so let's begin with a graph. It's a very basic equation, y equals 2x, which you're probably familiar with. The first thing I want you to think about is what's the gradient of this line. So just take a moment to think, what is the gradient? So as we know, in a linear equation where y is the subject, the gradient is just that coefficient of x, right? It's just 2. And there's a few ways we can do it. We could just know y equals mx plus c and just see that it's 2 by looking at the equation, or if you were looking at the line, you could use that kind of change in y divided by change in x method. So if I connect 2 points like this, make my right angle triangle, 2 is the change in y, 1 is the change in x, and 2 divided by 1 gives me 2, and that would work wherever I choose those 2 points on the line. So for example, if I chose these 2 points here, even though I've drawn a bigger triangle, it still gives me a gradient of 2, because the change in y divided by change in x is 4 over 2, which gives me 2. And with a linear equation, that gradient is consistent. So no matter where I'm looking on that line, the steepness, the gradient, is always the same. Okay, so that's what we're familiar with. But let's think, well, what would we not be familiar with? How about an equation like this? Okay, so you know this equation, y equals x squared. We should know what it looks like on a graph. But what if I asked you, what is the gradient of this curve? Just take a think, what would the gradient of this curve be? Well, it's quite an ambiguous question, isn't it? Because the gradient of this curve really depends on where you're looking. Because at some points, this curve is quite steep, and at other points, the curve is not steep. So for example, let's take this point here. Would you agree that at this point, the steepness of the curve is going upwards? We would say the gradient is positive. That's because if I were to draw a tangent, to the curve at that particular point, this linear tangent would have a positive gradient because it's going upwards. If I were to draw some kind of right angled triangle, we would say that the gradient is around 2, isn't it? Okay. If I chose another point, say here, would you agree that the steepness at this point, it's not as steep, so the gradient would be smaller at this point than the point before? Because if I were to draw a tangent, we can see that that tangent is not as steep. What about this point here? So take a moment to think, do you think the gradient would be positive, or would the gradient be negative at this point? Well, if I were to draw a tangent, as we can see that that line is sloping downwards from left to right, so we could say that it would have a negative gradient. And finally, what about this point here? What would you say the gradient of the curve would be at this particular point? So if I were to draw my tangent, you can't really see it too well, but I've got a blue line here. And because that line is perfectly flat, we would say that the gradient is 0. So a gradient of 0 is a perfectly flat horizontal line. Okay, so the point I'm trying to make is, on a curve, on a non-linear function, the gradient can vary depending on where you're looking. So if you change the value of x, so if you change the point you're looking at on the curve, that gradient can vary. So from September onwards, you're going to learn a skill that helps you calculate the gradient precisely at a particular point, and that skill is called differentiation. Differentiation is basically a formula to calculate the gradient of a curve. So, for example, in general, if you have a function y equals an to the power of x, so we're just generalizing by using random letters at the moment, but I'll show you it with concrete examples later on. If this is your function, the formula to calculate the gradient is anx to the power of n minus 1. Okay, so in words, that just means take your number in front of x, so take that coefficient of x and multiply it by the index, so the number on top of the x. So just multiply them together to get an, and then all you need to do, take 1 away from the index of x. Right, that might sound like a lot at the moment, but it's a relatively easy skill, and you'll be doing it with your eyes closed by Christmas, because you'll be doing it all the time. It's one of the most common things that comes up in A-level maths. Right, this dy over dx part, that's just a shorthand way of writing the gradient. Okay, so that just means changing y divided by changing x. Okay, so just a shorthand way of saying this is the gradient of the line. Okay. So this skill is called differentiation. Sometimes it's called different things, which is quite confusing. So sometimes people will call it the derivative of the function, or some people will call it the rate of change. But overall, the most common way of describing this skill is differentiation. All right, so let me give you some actual examples now. Okay, so I've just got my formula on top of the screen. And for each of these questions, we've been asked to differentiate the equation. So let's start off with y equals x to the power of 3. Let's think what would happen if we differentiated it. Okay, so starting off with y equals ax to the power of n, well, what would our value of a be? So it doesn't look like there's a number in front of x, but there is. What number really is in front of that x? What is our a? Well, the a is 1, and of course n, that index, would be 3. Okay, so just using my formula to calculate dy by dx, okay, I need to do a times n, so 1 times 3 to get 3, and then instead of n, I'm going to have n minus 1. So that's just a fancy way of saying just take 1 away from the power. So when I differentiate my equation, I have 3x squared. Alright, so at any point, please just pause the video if you want to try them for yourself, but I'm just going to go over these one by one. Right, so let's take this next equation, y equals x cubed minus 5x to the power of 2. Alright, well, when you have multiple terms in an equation, you just do this, but step by step. So you just do them one after the other. We've already differentiated x cubed, so I'm going to just put that down as 3x squared. Right, so we're happy with that bit. Now let's take the next term. What would the value of a be? Would it be 5 or negative 5? It's going to be negative 5, so don't forget the minus, and my power, so my n is 2 in this case. So just taking this term, a would be negative 5 and n would be 2. Okay, so all I need to do, I multiply a and n together, so I multiply the coefficient of x by the index, so I'm doing negative 5 times 2 to get the 10, and then instead of 2, or instead of n, we take 1 away from the index. So that 2 becomes a 1, but when you're writing things in index form, you don't bother writing the 1. So I've differentiated now, and that's my final answer, 3x squared minus 10x. Right, next one. Y equals x cubed minus 5x. Alright, so we've done the x cubed bit loads of times now, so we've got 3x squared, so that bit's done. But how would we differentiate negative 5x? Well, let's think. What would our a be? And what would our n be? So the a is just negative 5 like before. Do you see that n? If you've just got x, that really means x to the power of 1, doesn't it? So we've got negative 5 and 1. Okay, so differentiating that term in my expression, a times n is just a negative 5 times 1. And then I need to take 1 away from the power. So it used to be x to the power of 1, but now it's x to the power of 0. And do you remember from our GCSEs that anything to the power of 0 is just 1, right? So I'm not going to write x to the power of 0. I'm just going to call this just 1. So it's negative 5 times 1, which is just negative 5. So if you have something to the power of 0, really it's just a 1, so you don't need to write it down. So in shorthand, my simplified version is just 3x squared minus 5. Right, let's try a couple more. Again, we've done the x cubed part, differentiating x cubed, we get 3x squared. And then how would we differentiate just a numerical value? Well, really, there is an x here. Yeah, so it's minus 5x to the power of 0. So I can imagine this. If I wanted to write this with an x there, I'd put it as x to the power of 0, because anything to the power of 0 is 1. So these two things, negative 5 and negative 5x to the power of 0, are the same thing. So to make it fit my formula, I'm going to write it with x to the power of 0. And let's now consider, what would my value of a be, and what would my value of n be? Well, a would be negative 5, and n would be 0. plugging it into the formula, a times n was just negative 5 times by 0. Negative 5 times by 0 is just 0. So actually this term, it's like it disappears, because if you multiply anything by 0, it's just 0, right? And that works for any number. Okay, so if you don't have an x term, if you just have a constant term, so just a number with no x, that always just disappears when you differentiate it. Okay, so 3x squared is my final answer for that one. And then my last one, we know from the last one that if you just have a number term with no x's, for the reasons we just explained, that term will disappear, and then differentiating negative x cubed, that will give me negative 3x squared. Alright, so I've attached a worksheet to this post on Google Classroom with lots of questions for you to try. So if you want to take some time to practice this skill, please do, because as I say, it's the most important skill you'll learn in A-level maths. Okay, then these are the answers to that exercise, and I did include those answers in the worksheet as well. Okay, so let's apply this, because what we were just doing before, it's probably quite hard for you to see at this stage what you're actually doing and what that actually means. So I'm going to give you an example of the type of things they'll ask you, and I'm also going to include a picture of the graph as we're doing it, just so you can help visualize like what we're actually doing. Alright, so let's say they asked us this: find the gradient of this curve where x equals 2. Alright, so we have the curve y equals 2x squared minus 3x. Alright, so this is what it looks like. So it's asking us at the point x equals 2, so 2 along on my x-axis here, so it's this point here where I'm wiggling my cursor. It's saying what would the gradient be? Okay, so it's effectively asking for the gradient of this blue line. So I've just estimated what that tangent would look like, just using a very rough sketch by freehand. But let's actually do the maths. Let's differentiate this function to find the gradient at that particular point. So the first thing I'm going to do is differentiate. So can you think, how would I differentiate this? Well, using dy by dx, using my formula, just like what we've done before, that will give me 4x minus 3. So when I differentiate that function, I get 4x minus 3. Okay, so what do you think I'm going to do now? I have the general formula to calculate the gradient, and they give me a value of x. What do you think I'm going to do with this value of x and the formula? Okay, so what I'm going to do, I'm going to make a substitution now. I'm going to substitute in this value of x, because whatever value of x I substitute into the gradient formula, that will give me the gradient at that particular point. So what I'm going to do, I'm going to do 4 lots of 2 minus 3, because we're told to find it where x equals 2, which gives me 8 minus 3. Therefore, the gradient at that point is 5. So does that fit my sketch? Okay, remember, this was just a freehand estimate. So this is 1 along, 1, 2, 3, 4 and a bit, maybe 5. So it should be 5, 1. And that tells me the gradient of the curve at that particular point is 5. Right, so let's try another example. So you're very welcome to just try this for yourself and pause the video if you want, or if you're not sure, please just leave the video running and I'll explain it. Okay, so we have a curve, and just like before, we're asked to calculate the gradient of this curve at a particular point. So our strategy is we're going to differentiate and then substitute in that value of x. Alright, so lots of steps have been done in one here. So if you just expand your brackets, so use your grid method for the double brackets, then multiply everything by x, you would get this. So y equals x cubed minus 3x squared minus 4x. So once you expand it, the next thing you're going to do, you're going to use your gradient formula. You're going to differentiate. So calculating dy by dx would give you 3x squared minus 6x minus 4. Okay, so once you've got the formula for the gradient, now you're going to substitute in your value of x. Okay, so you've got 3 lots of 2 squared minus 6 lots of 2, and then take away 4 at the end. Okay, so just tidying it up, that tells you that on that curve, where x equals 2, the gradient of that tangent, the gradient of the curve, would be -4 at that point. Okay, so on your worksheet I've attached for you on Google Classroom, you've just got 4 more questions. Some are quite similar to what we just done, some are slightly different, but give these a go. The answers are on the worksheet as well, and I'll just put them on the end of this video as well if you're just working from the video. But please do just get in contact if you have any questions about this. Just write to me on Google Classroom and I'll get back to you as soon as possible. And these are the answers to this exercise. Alright, thank you very much guys. Yeah, let me know if you need any help.